So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is minimum cost to convert string part 2. So this is a very big problem statement, so let me just show you or explain what the question is saying. The question is saying that you are given a string source and you are given a string target, and you need to convert this source string to this target string with some operations on this source string. Now what are the operations and how you can apply the operations? So for the operations you are given one original array, a changed array and a cost array. So these are the three array given, and in each operation what you can do, you can take a substring of this source string s, let's say you name it x, and that substring x should be present in original. Now whatever this substring x is present in the original, whatever its corresponding changed part is, let's say it is present at index I, so you need to take that corresponding substring in changed of I, and you need to replace this x in source which changed of I. So we will discuss with the help of example also what is this thing, but yeah, let us discuss in terms of description of this problem. So you need to change this substring x to changed of I, and whatever this I is present in this original array, and it will take a cost of I. So this is what the question is saying, and also it is saying that if you have chosen a substring, let's say this, so you can't take another substring like this, you can't take this overlapping part. If you have chosen a substring, you can again choose this same substring also, but you cannot choose this overlapping part. So you can do the chaining transformation. If you have chosen substring x, so you can again take the same substring and convert it to some other thing. So you can do the chaining part also, but you cannot choose the overlapping substring. So let us see with the help of the example what the question is saying, so that you can understand in more better way. So this is the source string a b c d e f g h, and this is the target string a c d e e g h h, and you can see this is the original array. This is the original array B, C, D, F, G, H and T, H, H, and the changed array looks something like this: C, D, E, T, H, H and G, H, H, and their corresponding cost is 1, 3 and 5. That means if you choose a substring BCD from this source array, so this is present in this original array at this position, so you can convert this BCD to CDE with a cost of 1. If you are choosing a substring FGH, so you can convert it to THH with the cost of 3. So this is what the question is saying. So you can't choose the overlapping string, but you can choose the same substring again and again. So what does that mean? So in this case you can see, so you have chosen a substring FGH, so you can convert this substring to THH. Now you can again choose this substring THH, and it is present in the original array, and you can convert it to GHH. So you can convert FGH to THH, and then you can convert THH to GHH. So this is what the question is saying. You can choose the same substring again and again. So it is a kind of chaining transformation. So this is what the question is saying. Now let us see how we are getting this output 9, or let us see with the help of the explanation of the question how we can get this output 9, or dry run on this particular example test case. So yeah, we can see that A and A are matching, so we don't do any operation. We are just doing a simple dry run. We will understand the logic as well. So you can see this is BCD, and you can see this is CDE. So yes, this substring is not matching actually in the source and target. That means we need to convert this source string to target string with some transition, or source substring to target substring with some transition. So can we convert BCD to CDE? Yes, BCD to CDE is possible. So it will take cost of 1. So till now we have the cost of 1. So we have converted this BCD part to CDE. So you can see the next character is E. So E and E are matching, so we don't do any operation. The next character is F. So F and G are not matching, but there is no transition for F to G. So we will check FG. Again, F and G transition are not present in the original array, so we can't check F and G also. So we need to take the entire string till the end, FGH. So yes, FGH is present in this particular original array. So we can convert this FGH, but we can convert this FGH to THH only. So we will convert FGH to THH, that will cost us 3. So we have converted FGH to THH, but still it is not equal to GHH, right? We need to convert this FGH to GHH, right? So no problem, we have converted to THH. So THH can be converted to GHH, so we will again convert this to GHH. So indirectly you see we have converted FGH to GHH. So it will take a cost of 5. So you can see in the end our entire source string is converted to target string. So what is the cost? The cost is 5 plus 3, that is 8, 8 plus 1, that is 9. So the cost we are getting is 9. So this is what the question is saying. So how will we actually solve this problem? What will be the algorithm for this problem? So by seeing this particular thing, you can already have guessed the idea that we need some kind of graph or shortest path algorithm, because we have already discussed in the part 1 of the video, like there is a kind of multiple paths that we can get. So we need to choose this shortest path. So here also you can see the same thing. In the part 1 we had single characters, X to Y, Y to Z, and so on and so forth. Here instead of single characters we have substrings. So the same rule can be applied to substrings also. So if you have a substring FGH, so you can convert it to some other substring by multiple ways. There can't be a single way. You can take one example. Let's say you have a substring XYZ. You need to convert it to ABC. So there can be one direct way also which can cost 100 rupees, but there can be another way by which you can convert XYZ to EFG with the cost of 1, and then you can convert EFG to ABC with the cost of 1. So either you can convert XYZ to ABC with the cost of 100, or you can choose to convert XYZ to ABC with the cost of 2 by chaining process. So you can see there, for one substring to convert it to another substring, there can be multiple possible ways, and obviously we need to choose the minimum path, right? So this gives the idea of some graph kind of thing, because you can see we can consider this substrings as the nodes, and these edges, these transformation as the edges part, and these can be the weights of the edges. So you can see it like a graph also here, and to get the minimum path we will use some shortest path algorithm. So this is the basic idea of how we'll be solving this particular problem. So let us see in more detail how will we actually solve this problem. So let us discuss how will we build the logic. So basically in this question there are only two things important. The first thing is the minimum cost to convert a substring to some another substring. So this is the most important part. So what I am saying is that the first important thing is the getting the minimum cost to convert one substring to another substring. How will we break, and that is other part. First need to get the minimum cost. So what I am saying is that if we need to convert ABD to DCA, so one way is that we can directly do this conversion, or we can do some intermediate chaining process. So first we can convert ABD to CBA, and then we can convert CBA to DCA. So indirectly we are converting ABD to DCA only. So you can see there are two possible ways. So in this we need to choose the minimum possible way. So we have already discussed that we will build a graph and all of that, but which shortest path algorithm we will use? You can see there is one intermediate step in between. So you can see there is intermediate step in between. So this is the entire chaining, and chaining is built on the basis of intermediate steps. So whenever there are intermediate steps involved, what shortest path algorithm we use? We use Floyd Warshall algorithm. So to get the minimum cost to convert one substring to some another substring, we will use Floyd Warshall algorithm. So let us see actually what Floyd Warshall algorithm actually is. So if you are new that doesn't know what Floyd Warshall algorithm is, let us discuss what is this algorithm, so that when you move forward with this problem, you have the idea, okay, what we are applying and how we are applying. So let us discuss the Floyd Warshall part. So Floyd Warshall says what? Let's say you have one substring I and you have some substring j. So you need to convert this substring I to substring j, but we will check all the intermediate nodes in between. So what does it say? It says for each ith string, we will find shortest distance with all jth string, with kth string as intermediate. Same thing that I have told you. For each source string, we will try to find its shortest distance to all target string or jth string by taking all k strings that can be possible in between to give us this shortest path. So this is what Floyd Warshall says. So let us understand in terms of code. I am just giving the idea of Floyd Warshall algorithm. I am not going into much detail, because if I have explained the Floyd Warshall algorithm in more detail, the video will be very long. So let us see what the Floyd Warshall algorithm looks like. So we will take each and every intermediate string k. Now we need to get the shortest path from I to j. So this will give us the shortest path from I to j with kth string as the intermediate string. So what we will get actually? We will get distance of ij. The distance of ij is nothing but minimum distance required to convert this source string to this target string. This is what distance of I comma j is. Now we need to choose the intermediate k such that this intermediate distance from I to k and k to j, this is also minimum. So what we need to do? How will we get the distance of I comma j? So if we have previously stored distance of I comma j, either that will be the minimum or the new distance that we are finding, that will be the minimum. So what will be the new distance? The distance from I to j. How we can get? With the help of kth string in between. So first we need to get this distance I comma k. This should be minimum, and then we need to add it to this distance k comma j. This also should be minimum. So what we can do? We can get the distance of I comma k. That will give us the minimum cost to convert source string I to target string k. Then what we need to do? We need to convert this k string to j string. So in minimum cost. So what we will do? We will take distance of k comma j. So what this will give? This will give us minimum distance to convert this source string k to this destination string j. And combined it will give us what? Combined, you can see we actually convert this ith string to j string. So this will give us the minimum distance to convert this source string I to target string j. So what we can do? We can add distance of I comma k plus distance of k comma j. So either this will be the minimum or previously distance that we have stored, that will be the minimum. So whatever gives you the minimum, store the minimum result to this distance of I comma j. So for every source we will compute the minimum distance with every target. So this is what Floyd Warshall algorithm does by taking intermediate strings in between to give us the minimum cost. So this is what we are doing. So we will pre-compute the minimum distance for each and every source string to each and every target string. So this is what we are doing for the pre-computation part. So you can see here also how the Floyd Warshall algorithm looks like. So we have this ith string, we need to convert it to jth string with kth string in between. So first we need the minimum distance to convert I to k. So that is given by distance of I comma k, and then we need to convert this kth string to jth string, which is again should take the minimum cost. So that will be given by distance of k comma j. So our final distance of I comma j will become distance of I comma j equal to distance of I comma k plus distance of k comma j. So this is what Floyd Warshall algorithm looks like. So this was the first thing that was important. So we have discussed initially that there are two things important, right? There are two things important. So this was the first thing, to get the minimum cost. So what is the second important thing? Let us see now. So the second important thing is that how to split the source string or where to split the source string. Now this problem can be solved by DP. Now this is actually a hard problem because it uses the both of the hard concept in one particular question. So you can consider the graphs are also a kind of hard topic to understand and all that, and DP is also a hard topic to understand. So this question is combination of DP and graph. So this is actually a very hard problem, but yeah, we will make it easy for you. So the second part, like where to partition and how to partition it, we'll solve it by DP, because the partition thing always gives us the idea of DP, like which is the correct partition. Do we need to do partition here? Do we need to do partition here or here? Because you see, we are partitioning means we are choosing a substring. So where to partition, that is going to be decided by DP. So DP intuition is simple, graph intuition is simpler, but how to combine these two things, that we will also see. So what does DP of I say? So the DP of I say, what is the minimum cost to convert source from 0 to I minus 1 to target 0 of I minus 1. So if we are at I, so DP of I will give us whatever is the minimum cost to convert the previous thing from 0 to I minus 1. So if we have this minimum thing, so we can solve for this further part. So if we have done for the 0 to I minus 1, then we can find another minimum cost from I to some other j strings and all of that, j index and all of that. So this is what it look like. So if we are at this particular index I, so let's say we are choosing this substring EF. So first of all, we need to get the minimum cost to convert this substring to the target substring, and also to compute the final answer, we need to also have the answer for this part. What is the minimum cost till here? Then only we can add these two parts and we can say, okay, for this we have already computed what is the minimum part. So what DP does, this will be done by Floyd Warshall algorithm, the minimum cost. But the previous part, what is the minimum, that will be given by DP. So for ith string, we will get what is the minimum cost to convert source string 0 to I minus 1 with the minimum cost. So you can see this is source string from 0 to I minus 1. So this, what is the minimum cost to convert this particular source string to target string? This is given by DP. So DP decides which substring to choose and what position to choose such that the transformation cost is minimum, because obviously we can have many transformations possible. We can do a partition at this place, we can choose this particular substring, or we could have chosen these two substrings separately. So what gives you the minimum cost? So that DP will decide. So let's say you have already computed till here, so this is given by DP, and you have made another substring here. So this part will be given by Floyd Warshall algorithm, and this part you have already pre-computed. So Floyd Warshall gives you the minimum cost to convert this substring to the target string, and DP gives you what is the minimum cost till here. So combine this, you can get the answer for this part. So what is the minimum cost to convert this entire string to the target string? So this is how the code will follow. So this is how the logic will follow up. So till now we have decided, okay, we will use Floyd Warshall algorithm, we will use DP and all of that. But how will we apply the Floyd Warshall algorithm? How will we apply the DP? How will we combine these two things? So what will be the flow of the algorithm, that we will see now. So let us say the source string is this ABCDEFGH and the target string is this ACDEEGHH. So this is the second example, the example that we have seen while reading the question. So this is the same example. So you can write this example somewhere, because this will go up till very long, so I won't be able to come up to this part again and again to show you the source string and the target string. So you can note this source and target string so that you can follow up with the algorithm easily. And this is the original and the changed and the cost array. So first of all, what we need to do, we need to apply the Floyd Warshall algorithm, right? But we cannot directly apply the Floyd Warshall algorithm, because Floyd Warshall algorithm applies on strings, it applies on numbers, it doesn't apply on strings. So because we know that, okay, we need to get the minimum cost to convert BCD to CDE and whatever. So Floyd Warshall algorithm will not know what is BCD and what is CDE. We need to give numbers, so we will do some kind of mapping for these strings. So we can say that okay, BCD is given the integer ID as 0, THS has been provided the integer ID as 2, GHH has been provided the integer ID as 4, CDE has been provided with 3, and FGH has been provided with 1. So you can see, instead of saying what is the minimum cost to convert BCD to CDE, we can say what is the minimum cost to convert this string which is present at 0th index to this string which is present as 3rd index, because algorithm works in integers. So that's why we need to build first the mapping. So we will first do a mapping for string to index. Then we will apply the Floyd Warshall algorithm. So Floyd Warshall algorithm will give you what? The minimum cost to convert this string BCD to CDE. So this cost is 1. So what Floyd Warshall algorithm will give? Floyd Warshall algorithm will give the minimum distance to convert this 0 node to this 3 node, which is nothing but the minimum cost as 1. So this will give us the minimum cost. So this distance vector will give us the minimum cost. Now we have applied the Floyd Warshall algorithm. Now we need to think of the DP part. Now DP will try to choose each and every substring whether this position is correct to partition or not. But do we need to check all substrings? Just think, do we need to check all substrings of string length 1, length 2, length 3, and then again starting with some other index length 1, length 2, length 3? No, we don't need to check every substring, because we need to choose only those substrings that length are present in the original array. So you can see this was the original array. This was the original array. Our original array has only substring of length 3. So there is no point in checking the length 2 substring, length 4 substring, length 5 substring, because even if you get the substring of length 5, we don't have any length 5 substring in the original array. So there is no point in checking this substring, because we won't find any of these substrings present in the original array. So we will find what all unique lengths are present in the original substring. So in this case you can see the only length present is 3. So we will check each and every substring but only with length 3. So that is how we will do. So this will reduce our time complexity. So instead of checking each and every substring length, we will check unique substring lengths that are present in the original array, because in the end we need to convert the original string to this changed string. So that's why we should match this, whatever string we are choosing, that should be matched with the original string. So that's why we will choose the unique length substring which are present in the original array. So you can see here also the original has length of 3 only. So why to check the substring of other lengths? They will not exist for the transition. Obviously, if we have only length 3 substrings in our original array, so why to check length 2 and length 4 and all the other strings that are not for the transition, because transition can only happen that are present in the original array, and the original array has only length 3. So we will check only length 3 substrings in this case. If we have 2 length in the original array, let's say we have some BC and what you can say BCD. So in this case you can see there are two unique substring length present, 2 and 3. So we can check all the substrings with length 2 and length 3. So this is how we will proceed with the algorithm. So the solution is simple. Take unique string length from the original array. Now we will apply the actual DP part. So we are at index I equal to 0 first. So first, what DP of I denotes? The DP of I denotes the minimum cost to convert source from 0 to I minus 1 to target of 0 to I minus 1. So we are at currently 0. We can see this A and A matches. So we do not need to apply any operations. That means we can use 0 cost to convert this particular string. So what we will store? So till now we have the cost 0. So we have computed for the 0 index. For 0 index it will not require any cost. So what we can say, till 0 index the cost is 0. So we can say that DP of 1 will store 0. Why DP of 1? Because for this I from 0 to I minus 1 the cost is 0. The cost is 0 because you can see from 0th index to 0 index only, from 0 to 0 index the cost required is 0 because the characters are same. So DP of 1 can be stored to 0. So that is what we are doing. So at 0th index we find okay, these two strings are matching, so we don't need to convert this string with any cost. So the cost will be 0 actually. So dp of 1 can be set to 0 because source of I is equal to target of I. Now we could have also chosen some other substring of length 3. It is not necessary that okay, A and A are matching, so move forward. No, we can choose a substring ABC also, or whatever it has been provided, so that whether choosing this substring we will get a better answer in future or not. So we will check this also. So from the source string we can extract the substring of length 3 from the 0th index, so it will look ABC. And from the target index we can choose a substring of length 3 from the 0 index, so it will look ACD. Now we will check what is the minimum cost to convert this ABC to ACD with the help of Floyd Warshall that we have already computed. So we realize that okay, there is no possible conversion from ABC to ACD, so this thing is not possible, so this transformation is not possible. So okay, we will keep our answer as it is for the 0 part. Now we will be coming at index I equal to 1. So I equal to 1, the source of I is B and the target of I is C. So this is not matching, so we cannot convert B to C. So what is the next substring we can choose? We can choose substring of length 3. So we will choose substring of length 3. So from the source string we will get the substring as BCD, and from the target string we will get the substring as CDE. So now we will check what is the minimum cost to convert this source string BCD to this target string CDE. So this we will be getting with the help of distance factor, which is given by the Floyd Warshall algorithm. So we will get the minimum thing, or we will get the minimum cost to convert this BCD to CDE. Now obviously this exists, we have already seen this transformation can be done. BCD to CDE actually exists in our transition. So yes, this part exists, and what is the minimum cost? The minimum cost is 1. So we will add 1 to our cost. So distance of BCD comma CDE, or actually it will be in the terms of index. So distance of I comma 3, the CDE is present at index 3. So distance of 0 comma 3 is what? The minimum cost is 1. So what DP will store? DP of 4 will store this answer. Why DP of 4 will store the answer? Because we are at currently index 1 and we have chosen the substring 3. So from I to 3 we know the answer. So till 3 we know the answer. So I minus 1 is 3. So what will be I? I will be 4 obviously. So DP of 4 will store DP of 1. The previous minimum that we have till now. We have already seen in the explanation part. The minimum till the previous part plus this part that we will be given with the help of Floyd Warshall algorithm. The previous minimum, the dp of 1, the dp of I plus distance of 0 comma 1. So this is given by the Floyd Warshall part, this is given by the dp part. So the previous minimum that we have, the previous partition that we have done till now, what is the minimum, plus the partition that we are doing till now at this position, what is the minimum cost. So combined this will give us the partition till this part. So this will be giving us this combined part. So this is what the dp is doing. So in general we can say dp of I plus 1 will be storing dp of I plus distance of u comma v. This u is nothing but the index for this BCD and this v is nothing but index for this CDE. So you can consider this u and v as the nodes of the graph. And obviously we will be comparing it with the previous minimum, obviously the previous dp of I plus 1 and all that. But yeah, this is the general case that I am talking about. So this is how, I hope you understand what is the flow and how the code is working. So you can obviously forward with the I equal to 2, I equal to 3. If I show the entire dry run, this video will be very long. So you can try out these cases by yourself. But I hope you understand how we are getting the answer. So let us summarize what we need to do in terms of code. So first of all, we need to convert the original and changed string to integer form. So first we need to do the mapping from string to index or string to integer, whatever you say. Then we need to apply the Floyd Warshall algorithm. Then we need to get the unique length of strings that are present in the original array, because that length substring we will be choosing. So in our case, the only unique length was 3. So we would be checking only length 3 substrings. Then what we will do? We will use dp to know where to partition or where you can partition. So check all substrings of length which are equal to the unique length of the original array. So where to partition, so which substring to choose, we will choose the substring only which are of unique length in the original array. So we will check each and every substring, and this will go on and fill our DP array. So this will keep on going for each and every index I. For each and every index I, we will choose each and every possible substring and we will fill this DP array. So this is how we'll be getting the answer. So I have tried my best to explain till now. So I hope you understand. But still, if you didn't understand, let us understand in terms of code. So yeah, this is the code part. So this is the unordered map that we are using from for this string to integer conversion or string to index conversion. So for each and every string that is present in the original array and in the changed array, we are just converting this string into their corresponding ID value. And ID value we are just giving from 0 to whatever is the last ID that we have. So after pushing each and every string inside map, our map size will increase by 1. So we are just assigning the map size to the string values so that we can get index from 0 to whatever the map size is. So initially there is nothing stored inside the map, so first string will be getting the index of 0 because the map size will be 0. So when the second string comes, one element would be present inside the map, so second string will get the ID as 1 because map size will be 1. So on and so forth, we will be giving the ID to each and every index. Now we have just declared two variables n and m. The n is the source string length and the m is the size of this map. Then what we are doing, we are applying the Floyd Warshall algorithm. So Floyd Warshall algorithm will give us the distance array. This distance array will give us what? Distance of I comma j, minimum cost to convert this string I to this string j. So Floyd Warshall algorithm. So basic, we are doing this base scenario. Distance of I comma I will be 0. Obviously from source string to source string the cost will be 0 only. So we are just initializing with that, and after that we are just assigning whatever the direct transformations are there, the cost of the direct transition. So let's say for some particular string u to v, the question has provided the direct cost as 3. So we are just pre-filling the value with the direct transition part. The chaining part we will do with the help of Floyd Warshall algorithm. So we are just storing the direct cost here initially, and then we are applying the Floyd Warshall part. So k will be the intermediate string, I will be the source string, and j will be the destination string. So if distance of I comma k is equal to 118, that means till now there is no minimum value possible, so continue. Similarly, if distance of k comma j is equal to 118, so continue, there is no minimum value possible because we have initialized everything with 118. So this will take care what is the if there is minimum value or not. Otherwise, if there is minimum value present, we have seen in the code, distance of I comma k plus distance of k comma j we need to add, and whatever is the minimum, either this part or this part, we will store it into a distance of I comma j position. So this is the Floyd Warshall part. So this is the Floyd Warshall algorithm, and then we need to do the DP part. So before the DP part, we need to get what all unique substring length are present in the original array. So we are getting all the unique lengths of whatever strings are present in the original array. So we are just inserting in the unordered set. After that, we are doing the DP part. We are initializing everything with 118 because we need to get the minimum part. So we will keep as max value as possible. So initially the base case would be DP of 0 will be 0 only. And then we are going to each and every I and j possible. So for each and every I, we are trying to choose every substring length that is possible. So if the source of I is equal to target of I, that means it is simple. DP of I plus 1 will be DP of either minimum of DP of I or DP of I plus 1. We have seen in the first the I equal to 0 case, the A and A character were matching. So we have stored DP of 1 equal to 0. So this is what we are doing. So DP of I plus 1 equal to minimum of DP of I comma DP of I plus 1. Now we are checking each and every substring that is possible of length which are unique in the original array. So if I plus j is going out of bound, then there is no substring possible, so just continue. Otherwise, whatever substring we are choosing, extract it from source string and extract it from target string. So we are just extracting from I position to length j substring from our source string and target string, And now we have the string part. The Floyd Warshall algorithm does not work on string, it works on index or numbers. So first, whatever strings that we have extracted, we need to get their corresponding index from the mapping part. So we are getting the index in terms of u and v. So you can consider these u and v as the nodes of the graph. So we are getting the nodes. Now if these nodes exist, then only give us the minimum, otherwise it is not possible to do the transition. So if these nodes doesn't exist in the transition, that means there can't be actually transition from u to v. But if those transition exist, then the cost will be what? The cost will be distance of u comma v. So distance of u comma v plus whatever is the previous minimum that we have. So we are currently at this particular position, and previously we had the minimum till here. So previous minimum till here plus this Floyd Warshall part, this will give us the minimum till here. So minimum of so dp of I plus j will be what? Minimum, either we have some minimum already or the new minimum, that is dp of I till here plus this Floyd Warshall part. So this is what we are storing in the dp of I plus j. Now this will keep on going for each and every substring length and for each and every index I. In the end, what we need to do, we need to get the minimum to convert this entire string to the target string. So what we need dp of n. So dp of n will be storing our final answer. So if dp of n is equal to 118, that means there is no possible way to convert this source string to target string. So our answer will be -1. Otherwise, if there is one value present which is not equal to 118, then we will return that particular value, and that will be the minimum cost to convert the entire source string to target string. So I hope you understand this problem. I have tried my best with the help of examples, explanation, flow, summary and all of that. So I have tried my best to explain this particular question. So I hope you understand this question as well. So even if you have some doubts, you can write it in the comment section. I'll be answering that questions as soon as possible. So yeah, if you have any doubts, you can comment it in the comment section. But I hope you understand this particular problem. So thank you for watching.